Hello, everyone. My name is Abdullah Alharthi. I'm with the University of Manchester in the United Kingdom. I'm presenting my conference paper in the IEEE Sensor 2021. The paper titled Fusion from Multimodality Gait Spatial-Temporal Data for Human Gait Speed Classification. First of all, the objectives of this paper is advancing the analytical computing technologies for gait analysis by processing gait signals on data, on detecting pattern, by classifying gait into categories or pattern, and the fusion of different multi-source data. The potential applications of this paper are in human-vehicle interaction, for example, to assist pedestrian movement in proximity to self-driving cars. The other potential is in human-robot interaction to secure safety based on the prediction of human speed and movement direction on a shared and busy factory floor. In healthcare, it can be used as an indicator of cognitive decline in individual, as a tool to monitor the progression of Alzheimer's disease or aging or Parkinson's disease. First of all, we need to understand what actually is gait. Gait is a cycle, can be expressed as a cycle that exists in all humans. And this cycle is divided into two phases, the stance phase and swing phase. The stance phase is 60% and the swing phase is 40%. Stance phase has four major events and the swing phase has three major events. There are seven, and these seven events would take approximately 1 second to be executed. So it starts with the A, which is heel strike, and then followed by loading response on the mid stance, on terminal stance, on pre-swing, initial swing, terminal swings, which is A is the heel strike with initial contact, and loading response or flat foot on the ground. We are following the red leg in our graph. So it's, let's say, assume that it's right leg. So terminal stance or heel off on pre-swing, on initial swing, on mid-swing, on terminal swing. As can be seen that all of these events are very complex and it takes only 1 second to be executed and it occupy the space and time. So it's a spatial temporal type of events that can be recorded with sensors. Now, for this paper, to study gait, we acquired an open source data set gathered in Luxembourg rehabilitation centers in 2019, and the data is recorded for 50 volunteers, 24 women and 26 males. The data is recorded while the subjects walked 5 different speeds. So the first speed is from 0 to 0.4 meter per second. The second speed is from 0.4 meter per second to 0.8 meter per second. The third one is 0.8 to 1.2 meter per second. And then the subjects are asked to walk self-selected speeds, spontaneous speed, and self-selected spontaneous fast speed. So there are 5 speeds are recorded for each subject, and each subject performed each speed 10 times, so 10 trials. The data are recorded with the trajectory markers of 52 reflective markers placed on the body, as can be seen on the right figure. In the front, it's on green, and the back is on red. So it was on the shoulders, chest, pelvis, arms, legs, knees, and foot. And as well, the data recorded are force plates measurements of 3D ground reaction force. So the ground reaction force while the subjects walk is recorded by placing ground reaction force plates on the ground and subject walks on them. and as well the 3D ground reaction momentum and central pressure coordinates and direction of angle coordinates. Mind you, all these points or data recorded in the coordinate system, which is X, Y, Z in the 3 direction. And as well, the electromyographic signals are collected by 8 probes, can be seen as plaque patches, starts from E1 to E8. So we had 4 modality data recorded from 50 subjects, 24 male and 24 women and 26 men. We proposed in this problem a machine learning, and we handled this problem into a supervised classification. So we would feed the data and train a neural network, and then we will test the data and see how effective the data. So we used vision transformers. They are very new, and they gained a huge success in speech recognition and language translation and the natural language processing. We proposed the multi-stream CNN, which is the top one, and then to process the 4 modality data. And we proposed a hybrid CNN+LSTM network, which is B, the one in the bottom. And we used the statistical classifier algorithm, decision tree, support vector machine, and key nearest neighbor. We fed the data as can be seen, input 1, input 2, input 3, input 4, and so on for the other network. And then we did the convolution, max pooling, and so on until the output. And then we test the neural network. This is a multi-stream neural network. And the second one with the hybrid CNN+LSTM. Input 1, input 2, 3, 4, and then we do the classification. Now, for the classification result, we first of all trained the neural network on 40 subjects, and then we tested the neural networks or the algorithms on unseen subjects. So we hold 10 people data. We never show it to the model during training, and we only show it during testing. So the result is the multi-stream convolutional neural network achieved 97, and the hybrid CNN+LSTM achieved 96. These methods do the fusion, and while this method is only single modality, so it only classifies 1 data, and the transformer, we achieved the lowest result, which is 58, with 1 data, and plus minus 0.3% when we change the data. So if it's reflective markers, it's plus or minus, and if it's ground reaction force, it's plus or minus, and so on. And the decision tree also performed much better than the transformers, and then so on. And then the single stream, it shows that convolutional neural network with 1 data, it actually performed less, but much better from the other algorithms. So convolutional neural network is really suitable for gait. So we achieve high results. As can be seen, when we did the classification, we did it into 5 gait speed, and we noticed that gait speed 3 and gait speed 4, which is 0.8 to 0.12 meter per second, is similar to self-selected speed. So it means that all the people, the 10 never seen by the model, have self-selected spontaneous speed of 0.8 to 0.1.2. So what we did, we combined these classification into these 2 classes into 1 class. So we only had 4 gait speed. So we, as can be seen, achieved a really high result with the convolutional neural network, and it can be seen from the receiver operator character to the multi-class how the classification result with the false positive rate compared to the true positive rate. In summary, a real-world scenario we actually trained the neural network and tested on a real-world scenario by predicting the gait speed of 10 subjects never seen by the model. And we did a multi-modality fusion and achieved a higher prediction accuracy. The deep learning models have shown that it outperformed classical classifiers. In conclusion, this method can provide a starting point for a broad set of applications such as car navigation and scene involving pedestrians and the human-robot interaction, and clinical practice to diagnose pathology or monitor cognitive environment on stroke and elderly patients. Thank you so much. This is the end of my presentation.